Good morning, dear students. We have already started various methods to solve the recurrence equation. The first method that we have already learned is substitution method. The second method that we learn is master theorem. Today, the third method that we are going to learn, and the name of that particular method is called recurrence tree method. This particular recurrence tree method is very important to solve recurrence equation. And as per its name, we are supposed to draw the tree. If suppose we have to build a recurrence tree, right? What we are supposed to do? We have to build a tree. After building a particular tree, there are several things that we are supposed to do. We have to find out the height of that particular tree. Now, as we all know, the tree may be having two kinds of subtree. One subtree is the left subtree, this one, and you may be having the right subtree as well. Now, whichever tree is having the more height, that we have to consider. The second thing that we have to find out, that we have to calculate the cost of node at each level. As we know, root node is always at level 0, and subsequent level that children are going to be there at level number 1, level number 2, and level number 3, and so on. So, this basically recurrence tree is useful for visualizing what happens when the recurrence is iterated. It is a diagram, so you have to draw the diagram. So far, whatever the method that you have seen, you are not drawing any diagram, right? Now you are going to draw the diagrams, means we are going to draw pictorial representation. So this is a recurrence tree method is a pictorial representation of the iteration method, which is in the form of a tree where at each level nodes are expanded. In general, whatever the recurrence equation given to you, you have to consider the second term. Remember this particular term, right? This second term, whatever the recurrence equation is given to you. Say for example, the recurrence equation given to you is t of n, it is equal to 2tn divided by 2 plus n. So in this case, the second term is n. That you have to consider as a root node. And it is very useful. When this strategy we have to apply? So when you are going to apply the divide and conquer strategy, right? Where this recurrence tree method is really going to be very useful. To understand this recurrence tree method, let us take an example. The given example is t of n, it is equal to tn by 2 plus tn by 2 plus n. It is actually this tn by 2 plus tn by 2. So it is 2tn by 2. So this recurrence equation may be given to you people as t of n, it is equal to 2tn by 2 plus n. Now we have to try to solve this particular recurrence equation using recurrence tree method. As per the steps that I explained earlier, what we have to do? We have to consider this second term as a root node, right? And every time you know here we are having two terms. The first term, that is your left subtree, that I have highlighted using green color, and the second subtree, right, that I have highlighted, that is your right subtree, that I have highlighted using blue color. What you have to do? You have to generate this left subtree, and you are also supposed to generate a right subtree. And every time what is to be done? N to be replaced with n by 2, and for a right child n is to be replaced with n by 2, right? So if we do so at the very first level, right, now here you see it is actually 2tn by 2. So if we compare with the equation of master theorem, what is the master theorem? T of n, it is equal to atn by b plus f of n, where the value of a, it is equal to 2. Means what? Two children will be there. So this is the first child and this one is the second child. And what is to be done? N is to be replaced with this n by 2. That's why the cost at this particular level is n by 2, and also for this particular node the cost is going to be n by 2. Now if we calculate the cost at the root node, right, so the cost is going to be n, and it is calculated here. But at cost at this particular level number 1, it is going to be n by 2 plus n by 2. So ultimately it is n. So you see the cost at each level, it is going to be n, right, and it is, you see, if you observe again, if I replace n with n by 2, again I am going to get n by 4 here and n by 4. This is a recursive call, and that's why these equations are known as recurrence equation. This is your left subtree and this is for the right subtree. Means what? This n to be replaced with this n by 2 whenever you are drawing a left child, and whenever you are drawing a right child, it is to be replaced with again n by 2. This is a special case where either the left child or right child will be the same, or will be replaced with the same value n by 2. But means what? The meaning of this is the height of the left subtree and right subtree, it is always going to be the same. Again, if I replace n with n by 2, again I am going to get n by 8, n by 8, and so on. Now up to which point we have to repeat this particular process, right? Now we have to try to find out, and we have to try to observe the pattern. Here can we write, instead of n, it is n divided by 2 raised to 0, as we know 2 raised to 0 is 1, so it is going to be n. Here we can consider n divided by 2 raised to 1, n divided by 2 raised to 2, n divided by 2 raised to 3. Ultimately what we are trying to do, we are trying to find out the pattern. What is the pattern, right? So n divided by 2 raised to 3. So in general we have to repeat this particular process till the kth level, n divided by 2 raised to k, and when this value is going to be, when this value is going to be 1, we have to repeat this particular process, right? So here you see I have written that particular condition when n divided by 2 raised to k is going to be equal to 1. Now what I have to do, we have to take log on the both the side, and if you will take log on both the side, it will give us the value of k, and it is going to be log n base 2, and this is going to be the height of the subtree. Okay, but here in this case the height of the left subtree or right subtree, it is going to be same, right? So that's not any issue, right? And the cost at each level is, if you observe properly, the cost at each level is also same. So in that case the equation is, the time complexity will be height of the subtree multiplied by the cost at each level. So here in this case the cost at each level is n, the height is k, right? So it is going to be n multiplied by k, and as we have already found the value of k, it is equal to log n. So the time complexity for this recurrence equation, it is going to be order of n log n. I hope it's clear. Let us take one more example. It will make your idea even more clear. Here we are going to take different example in a way that every time n will not be replaced with the same value, but here in this case, as a left child, we are going to replace it with n will be replaced with n divided by 3, and the right child will be replaced with 2n by 3, because our recurrence equation is such. What is the recurrence equation? T of n, it is equal to t n by 3 plus t 2n by 3 plus n. Okay. Now if you remember the very first step, we have to consider the second term as a root node. So we have written this as a root node, right? Again the left child is to be replaced, n is to be replaced with n by 3. That's why the cost at this particular node we are going to get is n by 3, and as a right child we are going to get is 2n by 3. Again now it is a recursive call, so we have to consider this as a root node. Again the left child of it means what? The value of n is going to be replaced with n by 3, so we are going to get n divided by 3 into 3, so that is n divided by 9. Same way for all other nodes we are going to get the value. We are going to get 2n by 9 here, 2n by 9 here, 4n by 9, n divided by 27, and so on. Now as I explained in the earlier example, what we have to do, we have to try to find out the pattern. So here the pattern is like n divided by 3 raised to 0, n divided by 3 raised to 1, n divided by 3 raised to 2, and so on, right? So this is the pattern that we are going to get, and then what we have to do, we have to repeat this particular procedure till the point and we have to repeat this particular procedure till we are getting n divided by 3 raised to k is equal to 1. So here in this case, what is going to happen? N divided by 3 raised to k, it is going to be equal to 1. And this is the height of the left subtree, because we know on a right hand side we are not having n by 3 value, we are having 2n by 3 value. So we also require to find out the pattern here. The pattern is going to be, here we can write down n divided by 3 by 2 raised to 0. N divided by, this is 2n by 3 can be written as n divided by 3 by 2 raised to 1, n divided by 3 by 2 raised to 2, n divided by 3 by 2, 2 n divided by 3 by 2 raised to 3, and so on. So if we calculate the height of the right subtree, again the same way as we calculated for the left subtree, and we got the height of the left subtree is log n base 3. So here it's the same way, you will get the height of the right subtree is log n base 3 by 2. And as we all know, the height of the right subtree is going to be larger, right? That's why the time complexity it is equal to, and here you see we have calculated the cost at each node. Here the n by 3 plus 2n by 3. So the cost at this level number 1, it is going to be again n, right? So that we have to consider, right? So what is our general observation? That cost at each level is same. So again here in this case the time complexity will be n into k. So what is what we can write down? N multiply by what is the height of the right subtree we have to consider, as the height of the right subtree is going to be more. That's why the time complexity is going to be order of n log n base 3 by 2. I hope it's clear to you people. So here the similar kind of one example I am giving you as a homework. It is a similar kind of example. T of n, it is equal to t n by 3 plus t 2n by 3 plus n. So similar kind of example I am writing here. T of n is equal to t n divided by 5 plus t 4n by 5 plus n, right? So try to solve this particular example. Now let us take one example where the cost at each level will be different. So here in this particular recurrence equation, the recurrence equation is T of n, it is equal to 2t n by 2 plus n square, right? So now this 2t n by 2, right? So here 2 is there, means we can have left child and we can have a right child. The 2t n by 2 can be rewritten as like this, t n by 2 plus t n by 2, right? Plus n square. Now as per the steps we know for the recurrence tree, the second term is to be considered as a root node. Now left child is to be replaced, n with will be replaced with n by 2, and the right child also going to be replaced with n by 2. As the value is same for the left subtree and right subtree, we only have to find out the height of the subtree by considering any of the subtree. Either you may consider left or you may consider right. So if I replace n with n divided by 2, right? So I am going to get here n divided by 2 whole square and n divided by 2 whole square. So if I add, the cost at each level is n square by 2. Now cost at root node was n square, because we are having only n square here. Now you see, if you observe properly, the cost is getting reduced and it is reducing by half, right? So the cost at root node is n square, then at level number 1 it is becoming n square by 2, then it is becoming n square by 4, and so on. Now if we okay, one more thing, we have to also try to find out the observe the pattern. So here the pattern is n square, right? Right, so can we write down like this, n divided by 2 raised to 0 whole square? Very good, right? So n divided by 2 raised to 1 whole square, n divided by 2 raised to 2, that is 4, right? So n divided by 4 whole square, so n divided by 2 square whole square, n divided by 2 raised to 3 whole square. So we have to repeat this particular procedure till we get 1 here. When we will get 1 here? When n divided by 2 raised to k, where k is the level, right? So n divided by 2 raised to k whole square value is becoming equal to 1. But here in this particular case, the cost is not same at all the levels. So we can't apply that equation. The equation was height multiply by, what was the equation? Height multiply by the cost at each level, because the cost of each level was same, but here the cost is reducing half as we go from one level to another level, right? And it is reducing to half. So what is to be done? So we can observe the height is going to be same, but whatever the cost, highest cost that we have to consider, and here in this case the highest cost is going to be at the root node, and ultimately it is going to be our time complexity for the recurrence equation. But how to prove that? So what we have to do, we have to just add the cost at each node. So how, what to do? Cost at root node, that is n square, cost at node number 1, that is n square by 2, plus cost at next level n square by 4, the cost at again next level, that is going to be n square by 8. Now if I take n square as common, so cost, it is going to be equal to n square into this series I am going to get, that is 1 plus 1 by 2 plus 1 by 4 plus 1 by 8. Now above series is of the form A divided by A minus R, where R is the ratio. Now you see here in this case, every time the cost is reducing to half, that's why we can say the ratio is 1 half. That's why the cost is going to be equal to n square, I have written as it is, 1 divided by A is the first term in your equation, divided by 1 minus 1 by 2. So it is going to be 2n square. It is going to be 2n square. So we can ignore this particular constant and we can say the time complexity for this recurrence equation is order of n square, right? So now we have finished with all the three methodologies to solve the recurrence equation, and I hope you all are going through all these videos and whatever the assignments, questions that I have already shared with you people, students, right? So just go through those examples, solve them, right? And still if you are having any doubt, you can contact me. Thank you.